So in this video, we're going to continue to try to take a look at the big challenge of factoring trinomials in the form ax squared plus bx plus c. But we're also going to weave in a couple other objectives that it doesn't actually add to the difficulty. It gives you a way to sometimes get around the difficulty, or at least to be on the lookout for when you don't have to deal with the difficulty. Let's put it that way. So here's the objectives. First, to continue to build a general plan for factoring. We introduced that in one of the earlier videos. And then second, to begin multi-step factoring of polynomials. So I start with the general idea of, let's not forget what factoring is. Factoring is expressing something as an equivalent multiplication problem. So taking us all the way back to our earliest days, if I asked you to factor 42, whatever you write as a factorization had better represent 42. So 2 times 21 is a great start. That's the first step. If I asked you to factor it completely, if I asked you for a prime factorization, you would have to notice that 21 still has some work to do. Recognize that things multiply together to make 21. And when you factor for your next step, make sure all the pieces of 42 are still there. If you had just written 3 times 7, that's not a good factorization for 42. If you had just written 7, that wouldn't be a good factorization. So 2 times 3 times 7 contains all the pieces that are needed for 42. It's a fine factorization for 42. Next, let's also recall that our factoring plan that we were starting to build earlier, it requires us to notice the number of terms in a lot of ways. Trinomials, we factor a certain way. Binomials, we factor a certain way. 4-term expressions, we factor using grouping. But with GCF, you don't need to have a certain number of terms. GCF, if it's there, it's there. That could be for 2 terms, 3 terms, 4 terms. And that works out really nicely with this challenge that we've been dealing with recently. But I'll remind you, so this is a 2-term expression. The greatest common factor is a 3 and an A. You can factor it out and you see inside the parentheses 2 terms. Well, what if we had a 3-term expression? If you scan across and notice that each factor has a 2, or sorry, each term has a 2, each term also has an X. And we do like to take the negative out for reasons we'll find later on. Take out a negative 2x from everything, and you can go through term by term and say what's left. And those 3 terms that are inside here, if we wanted to reconstruct, we could, but we've done a nice job of factoring. And this doesn't have any symmetry that we like to try to react to. So there's no more factoring there. Okay, next, the last piece to recall is factoring ax squared plus bx plus c has proven to be more difficult than factoring when there was no number in front of x squared. And you might even think it's way more difficult, and I might agree with you. The guessing and checking, while steeped in our understanding, it's a challenge. So let's look at how this general plan for factoring might actually help us avoid some difficulty. So the general plan for factoring is going to now start with number 1, regardless of the number of terms, look for a GCF first. Not only did we just say GCF is available for any number of terms, if we think about the ones we've been struggling with lately, we might want to really be on the lookout for a GCF. Number 2 is going to be, if you take out a GCF, then see if any of the multi-term factors that you just created, like if there was a 2-term expression or a 3-term expression, if they could be factored further. Because if you get something that looks like this, your first thought might be, this is one of those ones where there's a number in front of x squared. The guessing and checking and the organizing takes a very long time. But that's if you're ignoring our first rule. Regardless of the number of terms, look for a GCF first. Because this 5, which is a in this thing we've been learning, it's actually also a common factor. So you could notice that every single term has a 5 in it, and you could factor out the 5. What's left then inside the parentheses is a 3-term expression, and that multi-term expression, unlike the last one we saw, this has that symmetry. It has that x squared, the x, a number, and you can ask yourself, if there's factor pairs of 3 that have a sum of 4, then we're good. 3 could be a 1 and a 3 that has a sum of 4, so yes, this 3-term expression does factor. Notice we didn't have to get into a whole deal of guessing and checking with these 5s and checking outers and inners and things like that. If you can strip away that lead coefficient using a GCF, it is going to open up, it's going to make it a lot easier for you. Now, you can't always avoid that, because in this example, 4x squared minus 27x minus 7, we still take a look for a GCF, and I think of 2s and 4s and x's and things like that, and I see no 2s, I see no 4s, I see an x, but over here I don't see an x. All right, so it looks like we don't have a GCF, so we're stuck trying to factor this thing, and I wanted to remind you how we factor that. So in the last problem, in one of the first videos we saw with these things, we talked about guessing and checking, and we were just being real systematic about it. We would think about this as maybe, let's break up the 4x squared as an x and a 4x, And let's try to break up the 7 as a 1 and a 7. And I was usually hitting smaller factors early and bigger factors later. And then the check, let's not forget, was this outer and inner, and see what those outer and inner products are. And we were supposed to find an outer and inner product that when you added those two products together, you got a negative 27x. So that didn't work. But we can start being on the lookout. We don't have to guess systematically if you start developing some number sense. I'm looking at what I'm working with, a 4 and a 7, and trying to get to a 27. I think I wanted to make my next guess so that my outer product or my inner product is a 4 times a 7. It gets you a 28. It gets you close to a 27. Let's try that as our next guess. So I'm going to make my next guess. Instead of going very systematically, I'm going to put my 4x here and my 7 here, again, creating a 28. Where does that leave me? Well, the 4x squared would have an x left, and the 7 would have a 1 left. And if I filled in my signs, it would look something like this. Let's see how we did. My outer is a negative 28. My inner is a positive 1. I did get my negative 27. I want you to notice that if I put my positive here and my negative here, the signs would have been wrong, but the numbers would have been right. And if you're on your toes, you find out you don't need to guess and check as dramatically as we've been doing it later. If you need a system, use a system. If you're developing number sense, it's going to help you out. There's one last thing to help you out if you don't have this number sense developing yet. And I'm going to show that in this one. First, I'm going to show you, if we were thinking about this example, we look for a GCF, we're going to be happy to find there's a 2 and everything, because at least the numbers get smaller. Your guesses would be a shorter list if you were able to take the 2 out. So we'll do that. And now I'm looking at the expression 3x squared minus 8x plus 5. That 3-term expression may just factor. So let's try it. Here's a guess developing. I need to break up the 5 now a certain way. And once again, you could be systematic about this, or you could be thinking number sense on this thing. If I have to break up a 5, so I'm going to get a 5 and a 1 somewhere, and I'm trying to create a negative 8. I feel like if I could create a 5 and a 3, I'd get my 8. And this would be the way to get that done. My outer is a 5x, my inner is a 3x. In terms of signage, if this was a positive sign here, we know that the signs we fill in here have to match. And if we're trying to match a negative sum, they have to be negatives. And we'll check it. Outer, inner, perfect. Okay, so we found our factors maybe a little bit more quickly than before. So what I'm trying to point out is all these things you learned about guessing and checking, couple it up with some number sense, and things might go a little bit better for you. So today's practice then is just going to be a little bit more of that, where you might take a GCF first out, and then you're also going to practice your guessing and checking and trying to develop number sense. So not too much new today, just some more time to get more comfortable.